Okay, good afternoon, good morning, good evening, everyone, depending on where you are joining us from today. It is an awesome time to be with you once again. And of course, data fluence, data fluence, data fluence. And there we are. Today is the next session to build, and we have fantastic people here with us. Let me quickly go through the slide before we proceed. So the slide before me is to, address our speakers. So once again, I greet everyone in the house that are watching. So today we'll be having a keynote speaker. Of course, we're going to hear her shortly. Then we have Mr. Paul, we have Mr. Samuel with us also in the studio. So I'll move briefly to the next slide. We want to appreciate our sponsors, our partners. Thank you for all the things you do for us. We are not taking it for granted. Of course, this is our keynote speaker all the way from South Africa. She is a manager at Microsoft, focused on empowering developers to build innovative, reliable, and scalable cloud applications. Of course, migrate to on-premise workload, to the cloud. She was named as an Inspiring 50 South Africa winner in 2020, and she's a member of the IHE Region 8. So she's also a founder of the Fala Him podcast and of course the Fala Him online community that digitalize African hymns. Through these initiatives, Level provided accessibility to African hymns and of course promote their cultural significance. And of course, here with me is Mr. Paul. Mr. Paul is a business intelligence architecture with over 9 years experience in building solutions for businesses. He's a certified trainer with passion for impacting knowledge. Of course, he's been adding value since I know him, community-wise, individual, corporate organizations. When he's not training, of course, he's doing something, building teams, of course, of intellectual people, intelligence, business development of around intelligence for the company he works for, and many more things about Mr. Paul. And of course, Mr. Sam would also be talking to us. So Mr. Sam is a Microsoft MVP, of course, one of the MVPs in the Africa region. Of course, it's from Ghana. Software engineer, of course, a technical lead with extensive experience. Of course, he's knowledgeable. Around application development, data analytics, Internet of Things, that's IoT, artificial intelligence, of course, mixed reality, and of course, ML, which is machine learning, and a lot of things. So before we proceed, we will need to hear from our that's our keynote speaker, and the next thing you'll be seeing now.
Market manager at Microsoft. I'm joining you today from.
All right. Thank you, everyone. Okay, just a moment. Let's see if we'll bring that back up. She sent this to us, so I believe this should be fine. So we'll bring that back up shortly.
A big thank you to the Niger Data Platform team, as well as organizers of the Data Fluence event. If it's your first time attending the Data Fluence 2023 series, note that this event celebrates the transformative power of data, as well as the boundless opportunities it presents to all of us. Today, we embark on a journey of exploration and learning, taking a deep dive into the heart of Microsoft Fabric, a remarkable tool that has the potential to revolutionize the way we work with data. Please stay in touch. My Twitter handle is @lebomadise. I'm also available on Threads using the same handle. So today's first speaker will be speaking about the fundamentals of Microsoft Fabric. At the heart of this event lies the quest to understand what Microsoft Fabric is. So it's not just another tool, it's an innovation that can harmonize your data universe Please embrace it as a catalyst for progress, as a means to turn fragmented data into a symphony of insights. Learn the principles and comprehend its architecture, as well as envision the possibilities that it unlocks. By mastering the fundamentals, you will be well equipped to navigate the ever expanding data landscape. Our second speaker will be speaking on the practical data integration as well as analytics techniques. The true power of Microsoft Fabric lies in its seamless integration of data as well as the profound insights we can extract from it. Embrace the art of practicality in data integration. It combines diverse resources, bridging the gap between structured and unstructured data, and witness the magic of turning raw information into actionable knowledge. Let analytics be your guiding light in decision making, revealing patterns and painting the path to success. The third speaker will speak on optimization strategies for performance and scalability. As we all know, with great power comes great responsibility. So, as data professionals or enthusiasts, please bear in mind the weight of optimizing performance and scalability. Understand that performance is the lifeblood of every data-driven operation. Strive to achieve efficiency, unleash the potential of your resources, and make data flow seamlessly in an unrestricted way using traditional limitations. Scalability, on the other hand, opens the door to growth and expansion. Prepare for the future by building solutions that can evolve alongside your ambitions. We've got a lot of data professionals, so data scientists, data analysts, database administrators, data engineers, data stewards, data citizens. In the world of the world of data realm is really a constant evolution. To truly make a difference, we must embrace the spirit of lifelong learning. Let us rise to the challenge of scaling up on Microsoft Fabric as well as other transformative technologies. Embrace the spirit of curiosity, innovation, as it fuels our journey towards a better understanding of data as well as its influence on the world. So, today, I'll also be sharing with you a high-level overview of how different data professionals from various industries and sectors are utilizing Microsoft Fabric to supercharge their data capabilities. We kick off with the data engineers. So data engineers execute faster, right? With their ability to spin up a Spark virtual machine cluster in seconds or configure with familiar experiences like engineering artifacts. As a data engineer, you want to streamline your work with a single platform to build and operate real-time analytic pipelines, data lakes, lake houses, warehouses, mods, and cubes using your preferred IDE, plugins, and tools. As a data engineer, you also want to be able to reduce costly data replication and movement with ability produce um, to produce base data sets that can serve data analysts as well as data scientists without needing to build pipelines. Some of the supporting experiences are the data factory, data warehouse, data engineering, as well as real-time analytics. The second professional is a data scientist. They quickly tune a custom model by integrating a model built and trained in Azure Machine Learning in Spark Notebook. They work faster with the ability to use your preferred data science frameworks, languages, and tools. With Microsoft Fabric as a data scientist, you'll be able to bypass engineering dependencies with the ability to use your preferred no-code ML ops to deploy and operate models in production. You'll be able to tap into proven at-scale models and services to accelerate your AI differentiation using Azure OpenAI or Microsoft Cognitive Services or ONNX integration, etc. Some of the supporting experiences are the Azure ML as well as data science. Next, we have data analysts. So as a data analyst, by using Microsoft Fabric, you'll be able to avoid slow progress which results from stagnating data wrangling by seamlessly triggering a workflow that can unlock data engineering tools and capabilities quickly. Accelerate your work with visual and SQL-based tools for self-serve data transformations and modeling, as well as self-serve tools for reporting dashboards and data visualizations. Turn data into impact with industry-leading business intelligence tools and integration with the apps your people use every day, like Microsoft 365. Some of the supporting experiences are data warehouse, real-time analytics, as well as Power BI. Next, we have data citizens. Make the most of data-driven decisions with Microsoft Fabric, with actionable insights and intelligence in your preferred applications. Microsoft Fabric helps you maintain access to all the data you need without being overwhelmed by the data ancillary in your role, thanks to the grain of data access management tools. Some of the supporting experiences are Power BI as well as Microsoft 365. Last, but certainly not least, we have data stewards. Data stewards maintain visibility and control of costs with a unified consumption and cost model that provides evergreen spend optics on your end-to-end data estate. Use Microsoft Fabric to gain full visibility and governance over your entire analytics state, from data sources and connections to your data lake to users as well as their insights. So, so as you go through today's today's sessions, I really encourage you to deep dive in the sessions and workshops today, as well as ask questions and foster a collaborative environment. Remember, each of us have something unique to offer, and together we can achieve remarkable things. The data landscape is vast, and we, the data fluence community, are at the forefront of shaping it. Let us seize the moment to drive a positive change in our organizations, our communities, as well as ourselves. I'd like to end off with a quote by my CEO, Satya Nadella, that states that data is the most critical architectural consideration. So he said this in his Build keynote of 2020, and it completely revolutionized how I think about data. So I really encourage you to make use of this opportunity, and your being here today shows how you are embracing new technology, and it will set your career apart from data professionals who are not looking to adapt and learn new tools. So stay in touch, join the Niger Data Platform Meetup group so that you can be informed about future events. So from me, Lebogang Madisa, thank you so much, and I really wish you a great day as you embrace your learning through the Data Fluence 2023 conference. Thank you.
Thank you from Southern Africa. We appreciate that time. Also in the studio with me, everyone. Thank you once again for being here at this time, Mr. Paul Barnabas.
Yes, thank you. Thank you for having me.
Yes, you have the floor, please. Go ahead.
Okay. Good morning, good afternoon, good evening, wherever it is you are joining us this day. Welcome to Data Fluence 2023. I've been introduced. Just want to speak a bit about myself. I work with 7 Up Bottling Company as their head of data management and business intelligence, where we talk about data governance, data quality, data management, business intelligence, and then ultimately, what we try to do is turn data into insights. Focusing on the discourse of today, we'll be talking about real-time analytics in Microsoft Fabrics. And just to put things in perspective, in case there's anybody who's wondering what is real-time, we'll just quickly go through a few introduction to talk about what real-time analytics is and also its context in Microsoft Fabric. So it's an end-to-end streaming solution for high-speed data analysis across the Microsoft Fabric. All right, it's optimized for real-time series data and support, and then it also help with automatic partitioning and indexing of data formats. Right. So what this simply means is that when you are working with huge load of data, it's some of the principles of storing data, especially when it is large, is to ensure that you are able to index that data and you are able to apply partitioning. Now, the beauty of real-time analytics in Fabrics is that it does this for you automatically. So you are able to walk through billions and billions of records or petabytes or exabytes of data, and you would not feel the pain. That's the beauty, right? It also helps deliver performance of data with various sizes, right? Ranging from gigabytes to several petabytes, right? So the analytic workload also can be used for solutions like IoT, log analytics in many scenarios, including manufacturing, oil and gas, and automotive, right? So looking at these different industries, we would see that at one point in the other, there's a need to always gather or acquire real-time data. And this data can come in form of a log. Maybe there's an application, an industrial application on a line, right? As the production line is going on and you are having products or items being generated, there's a counter that is counting real time. And all of this data, can be aggregated, accumulated. This essentially forms real-time data, and it can come across different sectors, even from sales, from the area of e-commerce, from the area of um, temperature sensing devices that capture, information per second. All of these types of devices or scenarios essentially provides or generates real-time data. Right. So, what are the advantages of real-time analytics? Right. The first one is, we're able to capture, we're able to transform and route real-time events to various destinations, including custom apps. So, with Microsoft Fabrics, if I am building a real-time analytic workload, I'm able to carry out all of these features. I'm able to ingest data and load data from any source and in any format. Is it CSV? Is it TSV? Is it Parquet? Is it coming from a lake house? Is it coming from a streamlined application or from an API? I'm able to gather data coming from each one of these data sources and then analyze them real time, right? I'm also able to run analytic queries directly on raw data without the need to build complex data. So one of the things we'll also see in the course of this session is how to utilize a new language called KQL. We'll talk more about that in the course of the session. So we can easily analyze, even do a bit of machine learning, a bit of AI on the data we are getting real time without having to write too much or too many complex queries, right? We can also import data by using default streaming, services that provide high performance, low latency, and high refresh rates, right? When it comes to data analysis. So this means that on the go, as data is coming in per second, we are carrying out analysis, right? It's not having impact on the load time, it's not having impact on the refresh time. The latency also is not essentially affected, right? So we're also looking at importing data. So imported data undergoes default partitioning, as talked about this the other time. that partitions and indexing are done automatically by default. So this ensures when we are querying, that database, right, is not going to slow down. Even though we have billions or millions of records, we're able to query them as fast as possible, right? So this also helps us work with different types of data structure, either structured data, maybe coming from a relational database such as SQL Server or Postgre or MySQL, or semi-structured. Maybe it's coming in a JSON format, it's coming in a in a XML format, in a text format. All of these different formats are essentially supported, right? So we can also query raw data without transformation, with high performance, low response time, and using different operator. So these are some of the features of that query language I'm talking about that we are going to use, right? So instead of you having to write so many lines of code, with simple lines or simple words and operators, you can achieve querying several thousands or millions of records, and it gives you response in real time. Right? So we're also able to scale to unlimited amount of data. So from gigabytes to petabytes with unlimited scale on concurrent queries. So what this means is that as the data are being generated on a day in, day out, every second, I'm also able to query that database. And notwithstanding, my data can grow as far as gigabytes, petabytes. It's unlimited. It's unlimited. And that's the beauty of Microsoft Fabrics, right? The real-time analytics within Microsoft Fabrics. And the last but not the least, we're able to integrate seamlessly with other experiences and items between the Microsoft Fabric. So remember that one of the holistic goal of Microsoft Fabric is that it's creating a platform for end-to-end analytics. So from me sourcing for my data, for me transforming my data, cleaning it up, loading it to wherever location I want, right? All of these processes, or either I'm enriching the data, all of these processes can be done collectively on one platform. So from Azure Data Factory, my data engineering part, my data science part, my real-time analytics part, my reporting part, my data governance part, all of these are covered in scope, right, within Microsoft Fabric. So I can create a workspace, and within that workspace, I have artifacts for extracting data, I have artifacts for databases, I have artifacts for data sets which are built off my database, right? I also have reports built on top of that database or those data sets. So it helps collaborative decision making or collaborative work process or workflow between data team. So either you are a data engineer, you are a data scientist, right? You are a BI developer or an analyst within a workspace or within the Microsoft Fabric platform, we are able to do end-to-end analytics. So that's the beauty of it, right? So let's look at use cases. So at what scenarios would necessitate me, utilizing real-time analytics. So if I have a data, that has a high refresh rate, or I want to be able to query that data real time, then I need to use a real time analytics solution, which Microsoft Fabric essentially provide. If I want to do quick transformations on streaming data, then Microsoft Fabric is the best solution. If I have services that need to access data with low latency, yes, Microsoft Fabric real-time analytics is the best use case. And also, if I'm looking at data in different formats, structured, unstructured, semi-structured, right, I can bring all of these data together, combine them, enrich them together, and make pre-informed decisions of those data. Yeah. So the ability to also query large amount of data, also data with time components that can benefit from real-time optimized data structure. So anything that is time-based, and you want to be able to do some time series, or you want to be able to do some anomaly detection, you want to be able to analyze based on information being generated on a daily or on a second per second basis, then Microsoft Fabric real-time analytics is the best solution for you, right? So let's just look at a diagram, a diagram of how to do an end-to-end data streaming consumption analysis within Microsoft Fabric. So as you can see on the left-hand side, I can consume data, as I said, from structured data to unstructured data, event streaming, a learning model. I can connect to all of these different sources. I can either using an event streaming module, either using the pipelines, data flows, right? I can establish connection to either one of these different data sources, right? And then I can ingest them, right? Either the pipeline or data flows I've talked about, or even to an Amazon S3 bucket. It's sitting in Amazon, different from Microsoft. I can have a Parquet file or a CSV file, or any form of file sitting in an S3 bucket, and I can just create a connection. And the beauty of this is that it's not going to copy the data over. It's simply going to establish a connection between Microsoft and that AWS artifact. And you are able to query that data or analyze that data as if it's within the Microsoft platform. That's one of the beautiful benefits of Microsoft Fabric. And take note that the idea we're talking about one platform is to ensure that there are no duplications of information or files. So I can have a particular file hosted right in a particular workspace and reuse that data in any other workspace I create, right? So that's the beauty. So it's a single source of truth when it comes to maintenance and creation of data within the Microsoft Fabric platform, right? So I can ingest this data into a KQL database. K means Custo, so Custo query language database. I can have that stored there or have it stored in the lakehouse or data warehouse, right? And then I can now expose the data or carry out different analysis of the data that I have in my database with the use of Power BI, or querying with a KQL query set, or with the use of notebook. So folks who are data scientists will use a notebook. We build machine learning models, or be able to even query, do some transformation, some EDAs, right, with the notebook. Or those who are familiar with SQL, data engineers that want to write KQLs or write SQL scripts, right, they will use this platform. And BI developers, right, can easily just connect to this database, right, or write queries, connect to the database, and they're able to analyze based on reports created from the database. So this is a simple end-to-end workflow of how to create, or how the a real-time analytic solution works within Microsoft. Right. So let's talk about the KQL. So I was saying Custo query language will be something we'll talk about. So I believe most of us might be familiar with SQL. So SQL is the query language. It's called SQL query language. It is the language used to query any relational database. Right. There are different flavors depending on the different vendors, but for Microsoft, it's called T-SQL, which is Transact SQL, right? You can either use Transact SQL or KQL to query databases, real-time databases, or any database, right? So the KQL simply means it's a read-only request to process data and return results. What this is mean, and to try and distinguish this between KQL and SQL. SQL is a bit more versatile, right? You can use it for different types of operation. But for KQL, it's just a read-only request to process data and return a result, right? The request is stated in plain text using data flow model that is easy to read auto and automate. So what this means, if you are used to SQL, you usually would reference as a select, you reference the columns you want, you specify which table you want, which filters you want to apply, and so on and so forth. But for KQL, you can just reference the table name, and then with the use of some delimiters or operators, specify if you want to apply a filter, if you want to aggregate. In the course of our demo session, we would essentially see how these work, right? So said query are always run in the context of particular tables or database. So just to put things in perspective, a bit of a difference to how SQL work. With SQL, you can connect to multiple databases across different servers, across different environments. But most times, KQL will simply work within the context of a table or a database. So let's just take note of that. Okay, so I think this is the time we've been looking for. Let's get to the practical session. Beyond all the talking, let's try and make a bit of sense of the introduction we've made. But I just want to ask if there are any questions at this point um, before we go to the demo session. I would love to take them now before we go to the demo session. Do we have any topics or any questions so far?
Not at the moment, not at the moment, but I'm sure while we'll go through that demo, if there are questions, of course, people will drop that and I'll let you know so that we can answer them.
Okay, thank you very much. So let
Great.
me try and share my screen now so that we can.
So just so you know, Sam has joined us in the studio.
Okay,
Just to mention that to you.
okay, thank you.
So please go ahead.
Please let me know if you can see my screen. If it's visible.
I can still see them. Are you sharing? You want to share your entire screen? We can't see it
Yes.
yet.
Okay, just a
I
minute.
can't see it yet. Okay, just a moment. This is your screen, so we can see it now.
Okay, thank you very much. Okay, so I believe we can all see. I'm currently logged into Power BI, right? So we would be working on this platform, Microsoft Fabric, for this demo session. So for the course of this demo, I'll be creating or I've created a new workspace that we'll be utilizing for the demo session. And just to put things in perspective, what we want to try and achieve, right, is we would create a KQL database. We will try and copy data, event stream that would help us copy data from that source to the KQL database. We would get some historical data. We will try and explore the data with the use of KQL and SQL, right? We would also do some advanced querying, with the use of machine learning to do some time series analysis, some anomaly detection, right? And then after that, we'll go ahead and build a Power BI report of the data that we've been able to harness. So that's the workflow of this demo session. So the first thing we are doing now is to create a KQL database. And how do we go about this? So as I've said, I've created a workspace. So to create a workspace, you come to where you have workspace and you click on new workspace. And once that has been created, you should have something like this. Okay, so I'm going to click on new and click on show all. And when I come down here, I'm going to click on KQL database. Okay, so we are going to call this um, NYC NYC Taxi DB. That's the name of the database that we are going to create. So what we are going to try and do is to connect to an event stream that generates data of the movements and activities of taxi in New York City, right? So we would connect to that event stream. We will be getting data that will be coming in real time, and it will be storing it in this database called NYC Taxi DB. Now, remember that I said that for resources that we create, right, we can create them in one place and utilize it across board. So for this particular database that I've created to be useful and to be available for use in other workspaces or within this tenant, I'm going to come here and turn on the availability of this database. So once I click on it as active, then I can utilize this link, right, to access this database from any part of my environment. So I'm done with that. So the next line of action is to create an event stream. So I'm going to go back to the root of my workspace, right? And I'm going to click on new, show all, and I'm going to scroll down to where I have real-time analytics. So under this real-time analytics, I'm going to click on event stream preview, right? So I'm just going to call this CD taxi. So I just call this New York Taxi Events Stream. Now click on create. So this is going to help me establish that connection. It's based on this event stream that I'm going to be able to connect to a Microsoft artifact, right, within Azure that accumulates or collects these real-time information. So automatically behind the scenes now is setting up a gateway between this instance and or my tenants, my Microsoft Fabric tenant and Azure, setting up all of the connection strings and then linking me to the source that I'm going to choose. So the moment I'm done with trying to set all of this up, it will have established a real-time, more like a direct query connection between Azure and this particular event stream, right? And then I'm able to pull in data, right? And data will be coming in, at a very frequent basis. So let's give it a few seconds for it to load, it's setting up the connection, it's trying to create all the links. Yes, so I have it. Now I need to specify what source, right? So as I said, it has established that um, event stream, but I need to identify what table or what information in Azure do I want to bring in. So I would utilize a sample data for this demo session, and so there are two different types of sample data. We have the yellow taxi and the stock markets. I'll be using this yellow taxi. So I'll call this CD taxi data source. Okay, and I'm going to click on add. Okay, so I've successfully added it and notice something. There is this icon showing in green saying it's streaming. So what this means is that it has successfully established connection, right, between that event stream within Azure and my current setup here within my tenant, right? So the next thing is to now set up where do I want this information to be saved within this workspace. So I'm going to create, remember we already created a KQL database. So I'm going to click on KQL database. I'm going to identify which workspace I want it to be inside the real-time analytics workspace, and this is the name of the database. And I'm going to call this cd taxi data. Okay. And I'm going to click add and configure. So now what it's doing is establishing and completing that cycle of go to Azure to the event stream, right? Establish a connection. Now, where's the destination? Where do I want to ingest this data to? I will specify a table and I'll call this New York City taxi data table. Just call it table. Okay, I'll click on next. Okay, so we can see it has done all of this for me automatically, right? So I have data connection name has been created. I don't need to worry about all this because I'm using a sample, but I have to give it a few seconds. It's trying to validate the schema, it's trying to validate some extract of that data that it will display, showing me that these are, some of the informations that I will be needing. So if I click on next schema, then I can now see. So it's going to try and load a preview of the data. So looking at this environment, we can decide to set the different types of data formats that we want this data to be stored within the database, right? So they can do for text, we can do JSON and Parquet, different CSV. All these are available formats that you can store your data in. But I'll be sticking with JSON. So I'll be storing this data as JSON, right? And okay, so that's fine. So this is sample, and as you can see, it has passed this data. We can see them, right? We can see these are a subset of the data that we want to try and bring in. Now, if you want to carry out some certain transformation, you can actually do that. Maybe, for example, change of data type. So I would love to do one or two here. So I want this to be an integer, my vendor ID, my passenger count. I would also want this instead of real to be an integer. This also, the PU location ID, I'll change it also into an integer, same as the DO, an integer. And I think I'm good. So these are the transformations I have carried out so far, and I'm good to go. So I'm going to click on next. So it's trying to complete the connection. So once this connection has been completed and is successful, what will typically be happening is data will be flowing into my KQL database real time. So as data is being generated from the source in Azure or in my event stream module in Azure, I get that data also replicated into this database. And as you can see, it's trying to load. So it's saving the destination and it's fine. And here I can see this notification telling me that it's currently ingesting, which is good, right? This is fantastic. So let's go ahead and let's go ahead and see the database that we just created and the tables that were just created. So I'm going to click on refresh. And now I can see that I now have table created, right? The new table, if you remember, we created a table called NYC taxi table, right? So I now have that information. And then I have some metadata. I have some metadata here that is showing me. So as I refresh the database, so let me click on this, the table. Yeah, just refresh the browser. I should see changes begin to occur as a result of data being ingested into the database. Okay. So as you can see that the numbers has changed. So one of the beauty of utilizing one lake within Microsoft Fabric is the fact that it's able to compress data. It does a huge compression of the data that is being ingested. So look at the original size of the data that has been generated, right, and see the size after it has been compressed. So it's achieving a 7.18 compression ratio, which is very, very impressive. Very, very impressive. So the next thing is, so you say we have data. So let's try and make sense of this data, right? Let's try and really start seeing what is contained within this data. So I can click on this check your data. It open like a window where I'm able to now run KQL or SQL. So I can query my database, right, with this interface. So I can achieve that either by clicking on this check your data, or I come to the table itself, click on this ellipsis button and write query table, and then I can use any one of these links. So essentially what they've done is to help you get started with KQL, right? There are list of examples of KQLs that you can quickly click on to give you, a guide on how to query the database. So I'm going to click on this show any 100 records. And as you can see, it has added that and it has run that query. So what this is saying is I want to query top 10 of everything that I have within my NYC taxi table. So this is the flavor. This is how KQL is essentially written. I specify the name of the table, there is a delimiter, right? And then I add whatever predicates or whatever filters or context I want to apply on top of that table. So take 100 means show me top 100 records or 100 rows within this particular table, right? So that's what that means. I can also go ahead and say, okay, for NYC, I want to see the schema. I want to get the schema, right? And what this will do is it will give me um, a rundown of the data type, the list of columns I have, their column ordinance, and the data type, right? So all of these, you can easily achieve. So if you just want to quickly identify a particular column, you can run this. You can also go ahead and say, okay, so let's utilize some of the ones that we have here, right? I can also say, let me change this to NYC table. Give me a count of how many records I have within this table. So it's saying I have 27,600 records so far. So in the last 5 minutes or so that we started running, this event stream to populate this table, we've been able to get 27,600 records. I believe also if I run it again, there might be slight difference as you can see. So in the last couple of seconds, a number of records has been included. So let me also do something here. Let's look at this. Um, I'm going to summarize this count now by the ingestion time. So I will do this for the last, so let me say for the last 5 minutes. So every five minutes is going to tell me how many the count of records or rows that essentially has been ingested into the table. So as we can see, between that's 245 between 245 and 250, 22,900 records, and between 250 and now about 10,600 records, right? So this is essentially, how to query the database with KQL. I can also do a few other things, right? I can say select. This is now means writing T-SQL. Select. So let me run this, and you can see it also works. It also works, right? It also works. So these are the different types of languages, KQL, SQL, that we can use to essentially query the database. Now, after writing your script, you can also save. You can save your KQL query, right, as a query set. And you click on Save as KQL query set, and let me just call this test, and I click on Create. Now, for us to do a bit of detailed analysis, right, because this database was just created and it has limited count of records, I would love to use one that I've created before. So I'm going to switch over to another workspace, right, and then I have this NYC tax DB also created there. But one of the things we want to try and do essentially is to do some detailed analysis, essentially do some detailed analysis, right? So we already saw the count. One of the things we can do is, okay, so I want to see in the last 10 minutes, what is the count of records or the list of records that essentially has been ingested into this table. And you will see that it's going to try and query the database and provide me that information. So you can see I'm using the where clause here. Initially, we were using the take the count clause, but now I'm using the where clause here, and I'm specifying the limits between. So in the last 10 minutes, and now give me the list of records, and I can see it. So about 59,100 records essentially has been inserted in the last 10 minutes. I can also say also visualize this data by date time, right? So, okay, so what I'm doing here is I'm getting the schema, but now I'm filtering on just date time. So tell me any list of column that contains date time. Please show me that list of column. If I do not apply the third predicate, right, or the third statement, it's just going to show me all of the columns that I have. Okay, I can run this also to show me, right, the last ingestion time. So this was last loaded, just barely few seconds ago was when this was loaded. Now, one very beautiful thing about this is that I can also create charts right from my query. So remember, this query now is supposed to summarize my count based on every 10 minutes. So if I run this now, as you can see, so in the last 10 minutes, it's showing me the count, the aggregate of records that have been inserted into that table. If I want to make a bit of sense of this data, I can say render this information in a time chart, right, or in a bar chart. And as you can see, awesome. It has created for me a fantastic visualization. So I can see the flow. I can see where there were low ingestion, where there was high ingestion. I can see a trend. I can see a trend of this. So very, very beautiful, right? I can also do counts where I'm doing like a group by in the context of SQL. So I'm doing a count against my PO location ID. And I can do a join. So one thing we are going to also try and do, right, is we are going to demo also in importing a data. So we used an event stream, but now we want to try and enrich this data. So I'm going to go back to my previous workspace, real-time analytics, and let's see how we can import data. So let's load a database. Let's go to the interface, and let's see how we can get data. We're getting data from a blob. So we'll be getting it from a blob container. So I'm going to call this location and click next. And then I need to provide the URL for that blob story, that blob container. So Let me get that URL from here. Somewhere here. Just a moment. I insert that script. Okay. Okay, so we don't waste so much time. I think I'll move on. Missed where I kept that script, but typically I will put in that script here and then it would show me the schema, and then I will be able to easily I'll be able to easily add that table. So I've already done that in my previous demo. So let me go back to that workspace and show you the data. So the data is what I have here in locations, and we can easily validate this. So let me check. Let me open my query sets. Okay, so I can do location, take top 100, and let me query from that table. So the new table is called locations, right? And what we have here essentially is like a dimension. So if you notice in our New York taxi trip, is containing historical information of the movement of trucks in terms of pickup of customers, the time it picked them up, the area, the location, the long. So, but within this dimension, I am maintaining the location ID, right? And all other attributes that speaks to the location that is being maintained within my transactional table. So I have the longitude, I have the latitude, I have the service zone, the zone, and the borough, right? So I can essentially create a join, a left join between this NYC taxi trip and the location. And how that is going to be done is I reference my table, my first table, which is NYC taxi trips. I'm doing a left join, and I'm referencing the columns that the join should be done on, which is on the location ID coming from the location table, and PO location ID coming from the NYC taxi trips table. So I'm going to summarize this information by the zone, which is this column here, and I want you to just give me the top 10, right? So I'm going to run this portion of the script, and voila, here we see it. So we are looking at the top 10. So it has joined, bringing this information from location. This information is coming from NYC taxi trip. And I can just go a step further and say, render this information in a column chart, right? And I begin to make a bit of sense of this. So, as I said, we'll be talking about a bit of advanced analytics. This is we doing anomaly detection. So I'm going to check the anomaly in the tips given by the customers in the Manhattan borough. So remember, we had the column for borough. We are filtering on Manhattan. We are still joining to our locations table, and we are creating a leg in the insights that talks about the tip, the average tip given within this time range for every 10 minutes, right? And then we're also extending, and we are adding that AI enrichment, which is utilizing a function of series decompose anomalies, right? So it's also going to create a line chart. So I'm able to juxtapose these informations together and see if there's an anomaly in the tip being given out, in the Manhattan borough. So I'm going to run this query, and then, and you can see a fantastic trend line. Now take note, The one in the red highlights are the anomalies, and S1 is simply the average tip. So these are average tips given based on time within the Manhattan borough. But all these points that we are seeing are anomaly detections. So this is giving me as so there was an excessive tip. So if we need to start investigating, we need to understand why were excessive tip given, right? What was the cause of that? Are there other things involved? Was it because um, the distance between the start and the end location, was very far, So, but this gives me a pretty idea as regards some of the anomalies that existed in the tip being given out during this trip. So the last one I want to look at essentially is looking at predictive analytics, right? So I want to ensure that the available taxi working in Manhattan Borough, right, is available to meet the demands during that hour. So I'm laying out, a forecasting function. It's going to help me create some analysis, and then I'm also looking at the count of trips that happened within a particular time. So I'm going to run this. So, and as you can see, right, the orange is showing the historical information, right, which is the use case in the past, how the data, how pickups were done within that borough, and forecast is the one in blue. So it's telling us that, right, with time we would need to ensure that we have enough trucks based on this forecast to ensure to meet the demand, of those trucks, of those vehicles within that area. So
Mr.
that's
Paul,
yes.
it's been awesome. People have been dropping feedback that they're enjoying your session, and of course, I believe everyone they are in love with this session. Let me bring up Mr. Samuel. Both of you will be here, so we can be in this studio. I mean, it can be here live. It's already loaded, and we cannot afford. So, Mr. Sam.
Hello. Can you
So,
guys
Mr.
hear me all right?
Good. Yeah,
Yes.
loud and clear.
Awesome. Awesome.
Loud and
Apologies for
So
the
I paused Mr. Paul
earlier.
because you're already adjusting to say is here. So we have it. Please go ahead. I just caught him, so it won't be as if I want him to hijack your session.
Welcome, Mr. Samuel.
So you have
Thank
it.
you. Thank you, Paul.
So you can take it away from here, right? Is that fine, Mr. Paul? I hope that's fine by you.
Yes, yes, please, by all means.
All right. Thank you. So you can share your screen. So while he's trying to share his screen, I've done its introduction, but I'll quickly do that again because he is here with us. So here is the great man called Sam Andre, the MVP, one of the strongest MVPs in Ghana. And of course, it's really a blessing to the community. Of course, I've read your profile before you get here, but people are already waiting to say, where is that person that I have already? so, so we have him in the studio with us, so you can take it away, please.
Sure. So whilst we I get my slides up for you, thank you so much for the introduction. Apologies for not coming in a bit earlier. Let's see. I guess I'll just go ahead and present my screen,
Okay.
and let's see. Okay, I'll go ahead and let me know here. Okay, so actually I'm going to share my entire screen,
All right.
share system audio as well, so that we can all see and hear. So let me know if you can see my screen.
Yes, of course. It's already here.
Awesome. So you can see my slides as well.
Yes. We are seeing your
Okay.
slide, not the entire screen. But
Awesome.
of course, you can see applications of real-time analytics in IoT. So
Awesome.
that's
Awesome.
that.
All right. Awesome. All right. So once again, thank you so much, and thank you, Paul, for getting it started. Because I noticed a couple of things you mentioned, and you probably explained and shown a demo for them to understand how that happened. So it covers some of the things for me to share with you to better understand what that is. So today we're going to be taking a look at applications of real time analytics in context with IoT. So what Paul shared with you is just one use case of real-time analytics. I'm going to take it a bit back and also look at the application of real-time, analytics in context with IoT. Like I've introduced, my name is Samuel Adranyi, um, all the way from Accra, Ghana. Microsoft MVP renewed. Currently, I do a lot of stuff privately with my little startup called Logic Solutions. I do a lot of community advocacy and community lead work as well. And those that are seeing me for the very first time, I stream at least 3 times a week. We're resuming all streams. I do IoT on Tuesdays. I try to demystify technology on Fridays, and then Sundays we delve into the Power Platform. But to everything, there's kind of like a story. I keep telling people that IoT and physical computing, it's in itself is something that has come to stay with us. It is with us. It's just that we probably don't notice that it's part of our everyday life. And the more reason why I want to drill down on that in context to real time analytics. I have a little story. So I like my beer a lot. And most times, I just pop into the fridge and take the beer and drink it, and not really keeping account of what's happening in there. And there was this day that I went to the fridge to look for a beer, and there wasn't any beer in the fridge. And I asked my wife a question: "What happened to all the beer in the fridge?" And she was like, "Gentleman, I don't drink the beer with you. You drink your beer." And at that moment, it hit me. I was like, "Wait a minute, how could I have drunk maybe 12, 24 bottles of beer in the space of how long? And how did that happen? Did I give some to people?" So immediately I was trying to understand my use, my the drinking pattern, how many I drank within. There's a lot of questions that was coming through, my head. And my wife was like, "Well, you are the IoT man. Put in some IoT and do some analysis to figure out what you do." And that became a project that I did, which is still in my house now. So if you follow my channel, you would see that. Now, what is the backstory to that? The backstory is that analytics itself is something that we need in our day-to-day life, whether it's a big business, whether it's a small business, it's part of us. We need to understand how things work around us. And today, that is what I'll be, delving into in context with IoT. And since we'll be talking about IoT, I think it makes good sense to actually explain to you or bring into context what IoT is, it uses, and then we can understand why it's important to put some kind of analytics and specifically in today, real-time analytics into that. So IoT I define as a network of internet connected things or objects, right? That is able to collect, exchange, and act on data, mostly without human intervention. So you see that there is a section of this that says act, collect, exchange, and act. So collecting the data and acting on the data. Today we're going to spend some time to understand how we act on that data in terms of real-time analytics. So if you look at the ecosystem of IoT or Internet of Things, how it's come from. Now you have a lot of devices, a lot of people, almost everywhere, any type of business, lots of common networks, and almost all around us 24/7, leveraging IoT. So it's very important that we see how we can layer some form of analytics to understand, how these things work. And that's what we're going to see today. So let me take you back a little, just to give you a little history about what IoT is, and then we can understand where we are with this kind of technology. So somebody might think that IoT in relation to analytics started really, like last 2, 3, 5 years. It's not even in the last decade. As far back as 1982, that was the first, original demonstration or use case of IoT, which is this Coca-Cola vending machine you see there. And the simplest form was reports the inventory, right? Inventory. whether it was whether the drinks that were loaded were cold or not, right? You would think, why does that matter? So we are going to appreciate and understand that, we're going to appreciate and understand that in context of that, it is very important, that you understand the use cases of applications of analytics when it comes to IoT, right? So in the industrial revolution, for those that don't understand or know, we are in the fourth version of industrial revolution. It started from automation, moved to big data, moved to cloud computing, and now we've moved to autonomous systems, and then IoT before data management. You see the last two of this segment, Internet of Things and data management. Now we're going to appreciate and understand the vast number of petabytes of data or zettabytes of data that is being generated by things, and how analyzing this data gives us the ability to manage and make insights and make decisions, right? So that's what we're going to do. I'll quickly share some projections with you so you understand how big this industry is and how big of data that comes in. So the number of IoT devices are projected to grow from about 7 billion as of 2018 to about 22 billion by the year 2025. And that's a huge number. Now, Gartner also predicts that as of 3 years ago, there were about 26 times connected things and people. Now that has gone up. That's about almost 30, 40 times. It's actually double, right? And McKinsey, as of now, there are almost a little over 150 plus devices that are connected to the internet every second. Every second. So that means a lot of data, a lot of resources, a lot of analytics, a lot of things, insights to gain. So it is predicted that as of 2021, there are about 520 billion in terms of the market value for IoT. So that's a huge market. Um, this simple analysis tells you the growth from 2019 all the way to 2027 in terms of the growth for IoT in all the dimensions. Now, let's look quickly at some of the applications of it and then where the insights and analytics come from. So we have consumer IoT. So you have your smart meters, your smart fans, your smart TVs, and all that. Home use. Commercial, you can have smart buildings, smart offices. Those form part of commercial. Industrial, you're talking about your industrial plants. You're talking about your assembly plants. You're talking about industrial agri and stuff like that. Then infrastructure, we are talking about smart cities, smart places. Now, all these things generate lots and lots of data, lots and lots of data. Now, to appreciate and understand the use cases of it and then how we apply it, I want us to watch this brief video to understand how they are connected and then why it is important to layer analytics on top of it. And let me know if you can hear the audio.
Today. People,
can we hear the audio?
Businesses, buildings, hospitals, factories, entire cities, and the billions of devices that connect us, the world,
awesome.
and to each other. This is the physical world. But what if we can replicate that physical world into its digital twin? A digital twin that is bound to the physical world in real time, that we can experience in mixed reality, that we can collaborate with, that we can run simulations on and find what is important to us, that we can apply AI to learn, predict, and act, to save time and money, to reduce carbon, to preserve natural resources, to improve safety, to bring us all closer. This is already happening today. Across the world, organizations are taking advantage of this new wave of innovation that trends to an interconnectedness that enables the metaverse. Everything modeled in the metaverse mirrors the status of its physical twin, including the interactions and relations between everything else. By applying the power of the cloud, we eliminate boundaries of what this can do. The potential is limitless. We can now track and analyze data from connected environments to identify patterns, trends, and anomalies. We can now simulate any possibility, evaluate outcomes, determine the impact of any change or condition. We can now harness AI to perceive the physical world to improve and automate tasks, to give superpowers to your frontline workers. We can now give everyone in your organization the power to build apps and workflows, to collaborate with each other in this virtual space, to share and receive expertise at the right time with the right context in front of you, to move through the physical world and get relevant information about its digital counterpart when and where you need, using mixed reality. The Microsoft Cloud brings these capabilities together with the limitless computing power of the cloud and intelligent devices at the edge, and creates this framework for building immersive and impactful digital twin, mixed reality, and metaverse solutions.
Awesome. Awesome. There are other videos, but pretty much for the sake of time, I know it's talking about the same things we're seeing over and over again. Now, if you listen carefully to the and watch the video, carefully, you will notice that almost all the sectors and industries of life were mentioned, from health to agri to industry to corporate to construction. Almost all the sectors or spectrum when it comes to our daily lives were mentioned in there. You realize that there are lots of data being generated in all these areas. And you could understand that making decisions, taking action, all right, doing predictive, anomaly detection. These are some of the insights and benefits when we leverage, real-time analytics on top of IoT, which is all around us. So question is that, so why real-time analytics, all right? Now, as you saw from the video, they talked about digital twins, which is a representation of, let's say, the physical asset. You realize that there was a whole building and they had a digital version of that building somewhere. Now, in if I am a property or asset manager, all right, and I have this digital representation of a physical asset that could be miles and miles and miles away from me, all right, but thanks to the power of the connection of the cloud, the twin can actually tell me the status of that building in terms of what is the what is the temperature in most of the building, what is the power utilization, what is the room occupancy, are we going over the weight, do we have to stop some of the elevators, do you have to send emails to figure out whether people should move away to use other resources that are being used, should we turn off the lights and conserve energy in other places where people are not. These are a lot of things or decisions that you can act on based on an event that may occur. So a single event may, prove greater for you to understand in terms of how you respond to it. I'll give you an example. Let's say there are only 3 people in the building and all 20 or 50 air conditioners in the entire building are running. That is not an efficient use of that energy and resource, right? But thanks to data coming in through IoT and the analytics layered on top, it can say that, hey, there are only 2 people in this building, based on data coming from IoT devices. And therefore, it is not prudent to keep all air conditioners in, right? So why don't we just turn everything off and leave in the rooms or places where the people are to use air conditioning and conserve some energy? That is an example of why real-time analytics is important. Now, other examples would be smart grids, like your smart meters, um, that give a lot of data, like how much current you're using, how much data is coming through it. Sometimes also you need to know. Another example is if you're using a smart water meter or using a smart electric meter, the power company needs to know, hey, are you running out of credit, so they can shut the meter down so you don't have power, or should they notify you when you're getting to a certain threshold? Now, the different metrics that you can apply when dealing with the real time analytics. So these are just basic reasons why it is important to have real time analytics. However, so why? We know that we need to have it, but why? Now, one of the key things is identify anomalies, right? Such as manufacturing defect or process deviations. Now, this can happen on the assembly floor or the factory floor, right? Where all these, you remember we said industrial IoT, where all these industrial machines are sending sensor data, and for you to make analysis on these sensors to figure out whether they are working properly. We'll get to understand the type of analytics and and dive more into it. We can also talk about predictive maintenance on devices, right? To say that based on the data that has been coming in, we can infer that in the next 3 4 days or 4 weeks, this particular device or this particular hardware would be in need of servicing. And for that matter, we can start the requisition or procurement or procedures to initiate that request. We don't have to wait for it to break down before we are rambling to figure out, hey, who can fix it? Where do we have the engineer and how can we schedule them? Now, then again, real-time operational dashboard. I made a case with the smart meters where your power company is looking at real-time dashboard to tell, okay, how is the power being used? We realize that in peak hours, there's a lot of usage in this particular area and then less usage in this area. And therefore, we can determine that let's divert or concentrate a lot of our power generation into this area because they are high peak or high use cases. Then we can also talk about inventory optimization in the areas of retail. So back to the first IoT device, which was the Coca-Cola vending machine. If you think about it carefully, now that IoT is more advanced, thanks to analytics, real-time analytics that come in time, we can tell from the retail side of things which of the dispensing machines is running out of the drink, right? That is one. So you have a fleet of all these dispensing machines. You can tell the quantity, and based on the number, you can now actually plan your route and say, okay, based on the analytics or data that is coming in, we can analyze and take and realize that the vending machine in city A is running out faster compared to that in, let's say, in site B, and therefore let's plan your route so that sorry, you replenish site A before you go to site B. That is optimizing fleet management, optimizing fuel economy, at the same time making sure that the right dispensing machines are getting the right product at the right time. Also, supply chain optimization. This ties into the example I just gave. If you are able to tell in real time which of the dispensing machines are going down, you can start your own supply chain request to replenish those how do you call it, those vending machines. So what makes IoT analytics different from the vast type of analytics that you do? First of all, we're talking about more data. The video you watch, buildings are sending data, devices are sending data, our cars are sending data, even in our houses, our watches, smart watches, all these things are sending data, our phones are sending data, right? So first of all, what makes it different and challenging is that the high volumes of continuous data in motion from multiple sensors, and all these sensors, right? This makes it also, it means you are storing and blending and managing different time series data, the time they're coming in, temperature, humidity, the location, the orientation, all these things are coming in. The second part why IoT analytics is different is that it is more complex, right? You're using different analytics techniques, and real-time analytics is one of them, right? You can also have distributed analytics on the edge in areas where connectivity becomes a problem, where you cannot apply AI models from the cloud. That has to happen on the edge. That is also something that you need to look at. Then it is more autonomous. You realize that when I defined what IoT was, we mentioned that network of internet connected things that could collect, right, exchange and act on data, in most cases without human intervention. So more of these things are autonomous. Your watch is sending data, your phone is sending continuously without your intervention. So how then do we deal with all this data coming in automatically, not us determining, hey, send this data by this time during this time? That is also another segment of devices, but generally IoT devices are more autonomous and they keep sending data. So this is what makes it a bit different, and therefore we need to apply different forms of analytics, and even in more cases, real-time analytics that works best for IoT. So what are the types of data analytics, or generally data analytics, that you can add to IoT? Before, we know that real time is one, but generally what are the types? So we have the descriptive analytics, right? That pretty much allows us to define what a set of IoT devices are supposed to behave. You have diagnostics analytics. That is what helps us to do anomaly detection. And you realize that Mr. Paul mentioned about anomaly detection when we talked about the spikes in tipping, right? How do you call that type of analytics? That's what we call diagnostic analytics, because you're looking at past data and figuring out, well, based on the trend, this seems to be abnormal, and therefore let's look into it, right? Then we can talk about predictive in case of machines and devices. I mentioned that based on the data and trends that we have and the analytics and AI we've used, we can tell that every 6 to 7 months, we need to service this air condition. We know that every 2 to 3 months, we need to service this device. We need to replace this part. We need to do this because all the parts are sending data, right? Then there's also prescriptive analytics. Prescriptive analytics is just an advanced form of descriptive diagnostics and predictive. They add more insight into it to understand. Now, in all these things, we have real-time analytics that helps us to define, in identifying whether we need to, define how the device are supposed to look like, whether we need to do, maintenance, do some diagnostics. That's real time. And that is what we're talking about today. Real time is giving us the data continuously in now, not in a scheduled manner. And therefore we can act on it to know whether we need to diagnose, whether we need to do some predictive maintenance or do descriptive analytics. All right. Then we can talk about edge analytics. So edge analytics is basically the location where the analytics is happening. Now, analytics can happen in the cloud or in the edge, right? But most cases, depending on your deployment or use case, it could happen on the edge. Maybe you are in a field or place where there is lack of connectivity, or your AI models and your inference models can be kept on the edge, localized, so that the data coming in is going through your edge and doing the analytics. Then we can talk about cognitive analytics. This is where you're applying also AI, but cognitive AI models to act on the data coming in to figure out, what decisions to be made. Now, I'll tell you something about, if I'm sure most of you, have seen aeroplanes and all that. If you didn't know, Rolls-Royce is one of the biggest manufacturers of aeroplane or jet engines. Yes, Rolls-Royce. There's also General Electric, but majority of them is Rolls-Royce. Now, for some time, Rolls-Royce was selling their jet engines to Boeing and Airbus and all the other aircraft manufacturers as part of the supply chain. After a while, Rolls-Royce decided to go with the lease system, where you see an Airbus or you see an aeroplane, but the jet engine on the aeroplane is actually on lease or has been rented to the airline by Rolls-Royce. Now, why and how are they dealing with this? Most of the jet engines that Rolls-Royce manufactures now all have thousands and thousands of sensors in the jet engine that are continuously streaming data, in this case, real-time analytics being sent through the cloud in the edge, being sent for all these type of analytics. Now, what this means is that Rolls-Royce can now see the performance of the engine to figure out if it's working in the defined way, in this case, descriptive, to check whether something is off, in this case, diagnostic analytics to do some anomaly detection, and then to actually figure out when that jet engine is due for servicing or repairs, which is predictive analytics. And then on top of it, layer some prescriptive analytics in the sense that, hey, send real-time alerts to the pilot or the airline to say, what, if you fly at maybe a lower altitude and you reduce the speed a bit, you can actually give the engine a longer lifespan. All right. And this is happening because there's real-time data being sent either to the edge or the cloud, and analytics or AI inference models are being done on it. I hope this, this is giving you some insight into it. So here's an example of an Azure IoT reference architecture for some IoT service. Now, if you look closely where there are two parts when the data comes in, right? So the devices could be anything we mentioned. It could even be your shoes. It could be your shirt. It could be your watch, anything that brings in data. Now, if you look at the hot part is where a lot of real-time or stream analytics happen, right? So the data coming in, they have a lot of inference models running on it to do all this analysis, figure out, hey, this data coming in, do we need to act on it? Are we going to do some predictive analytics? Are we going to do diagnostics? Are we going to do descriptive? Are we going to do all that is happening, right? And Mr. Paul explained and even showed you how to do that. So some of the data coming in, like the data coming from the New York taxis, can also be streamed to this model through now Microsoft Fabric to do some analytics in there. You could also pipe this data, this real-time data could be piped into a machine learning module to say that, hey, This is new data coming in. Continue to use this real-time data to train our models so that we can better perform analytics and get good results. Now, all these things, what is the end goal? Again, decision making, whether you need to start a service maintenance, whether you need to request for more supply, whether you need to um, um, send data, whether you need to adjust the performance of the devices. These are some of the outputs or outcome when you use real-time analytics, especially in context of IoT. So let me give you a use case before I wrap up. Um, Connected cars. All right. We are in an era where there are smart cars, electric cars. How do you even determine when to charge the car? How do you determine, all that? Now, in the case of a connected car, the huge amount of data, that the sensors in the car actually emanate or give out, right? In the advanced countries, a lot of the insurance companies actually tap into this data to determine whether a driver has been a good driver and therefore they need to reduce or increase their insurance premium. See, that's another smart way of using real-time data to inform decisions, all right? So connected in the case of the connected car data, the data that comes in, some of the analytics that the outcomes of analytics that that comes in is understanding the driving style. All right. So based on the data coming, we can segment and figure out, okay, so how is this person driving? Is he a safe driver? Is he a reckless driver? Is he in the middle? Because you have a lot of data coming in, and can compare with that. Then we can also say it can also help us to create what we call driver segmentation. Does this person, once you understand the person's driving style, you can create a segment and say, okay, this person belongs to the risky drivers. This person belongs to the safe drivers. This person belongs to the newbie or in between drivers, right? Then what can you do with that? Once you have that information, you can actually identify those that are risky, those that need to be, those whose premiums need to be increased, those that need kind of like a reward for being good drivers, or those that need to, that need a cut on their premium. You can identify them. And then you can now create the risk profile. And based on that, your insurance adjusters can say, hey, the next insurance cycle, you're going to pay more because you're being a bad driver. Or hey, because you're being a good driver, in the next insurance cycle, we're going to reduce your premium a bit. All right. Now, this also allows you to compare what we call micro segments. It allows you to compare a lot of data sets to figure out whether you are on the right track, even as a business, to perform gains or not. And we've seen that in the demo that our last speaker shared. So, without taking much of the time, that is the insight when it comes to the real side of the real time analytics in context with IoT. And I'm grateful to Mr. Paul for giving us the demo for a lot of the things that I have talked about. So in creating the demo that being the same thing, I'm sure maybe another time I might probably come in to show you physically how we collect some of the data from these sensors and then push it into a repository, and maybe Mr. Paul can take it from there, the data that has come in, and then he can do the analytics on that data. With that said, I want to say thank you again for this opportunity. Feel free to drop questions, Mr. Moderator, by any. I'm open to answering them. And if you have any questions for me, you can connect to me on all these social media platforms, and then I'll be glad to answer and guide you through an understanding the world of real-time data analytics, and especially in context with IoT and other real-time sensor data. Thank you very much. Can you still hear me?
Yes, I can hear you loud and clear. I'm saying
Awesome.
that some of our participants were asking that they enjoy the breakdown that they were just waiting for you to demonstrate. Um, so, do you want to show? We still have some few minutes. Is there anything you want to show? Mr. Paul, if you are in the studio, just let me know if you want to also tidy up so that we can leverage on
Yeah.
the field.
Yeah. Yeah. So with the with what Paul shared, that is just picking up from where I did. So that's why I was initially supposed to have started. So ideally, what would have happened was that all the sensor data coming from my IoT devices, my lights, my air conditioners, my car, would have been stored in a repository. In this case, the New York taxi data set that Mr. Paul used. So then we can do the inference on it and say that, hey, based on the data coming in, is the air conditioning working at the peak season? I'll give you another example. Let's say in a big managed building, right? When the temperatures in the room or probably outside, right, is cooler compared to the temperatures inside, it might be a good time for the device in terms of real-time analytics to send the facility manager an update that, hey, it looks like the temperature outside is very cool. Would you want to conserve energy by shutting down all the air conditions and telling people to open their windows and enjoy some fresh air, right? That is real-time data analytics coming in to tell him that, hey, look, we could conserve about 5% of our energy if we shut down the air conditionings and open the windows, because the data coming in from the sensors outside tell us that it is cooler outside, the air outside is cooler and not hot. So that's one use case of that. I talked about the connected car in context with insurance, right? Where there are these things on cars, I think that are manufactured from the 2000s upwards, called the CAN bus, right? Which is just a small port under your car. So for those of you who take your cars for diagnostics, they put something under it and then they're able to tell you what is wrong with your car. Now, the similar devices, IoT devices that can be put into cars, right? That send down all the sensor and all the driving habits or everything into that device. That device then sends all the data to the cloud or to the insurance companies, where they have created their AI models or analytics model to determine, is this person driving safe, or is this person keeps applying the brakes? All this data is segmented to figure out how to do it. And the example Mr. Paul shared is the process is the same thing. The only difference here is where the data set is coming from. So what Mr. Paul shared, the data was already there. You didn't know how the data came there, but IoT is how the data came there, right? For Mr. Paul to use that to do the querying and all that. So it wouldn't be any different from what Mr. Paul did. Maybe I think the part that people are curious to see is how do we get the data? I didn't focus on that because it wasn't an IoT session. I just wanted to elaborate on the importance and the use cases of real-time analytics in context of IoT. If they want to see that, I'm happy to come back and do a whole session on how to connect to devices and bring the data for analysis. I'm happy to do that at another time. But because today is more focused on the analytics, real-time analytics on IoT devices, that's why I left that that part out, because Mr. Paul had actually shown how to do that.
Yeah, thank you for that. Of course, the feedback was that they enjoyed the session, the breakdown, the scenarios. I mean, the cases that you have mentioned. Of course, everyone knows that. I mean, that is the way to go. That's the future of all those things that we have around us. So it's been a nice session. Of course, detailed, broken down. Of course, as a person, if this has come earlier, I would have prepared my mind for what Mr. Paul was. Now you get.
Yeah.
So I think that's why people were getting, I mean, giving us that feedback that I hope that we'll be able to say that. But of course, he has assured us that some of that time he will be with us. I mean, he's going to just show this from beginning to the end, like end to end thing. So of course, you have that from us. So thank you so much. Everyone, we have dropped feedback in the comment. This is just to let you know again. I will want to get your feedback. Of course, one of the reactions that we have gotten today is that I mean, people have responded that the session is calm, like there is no pressure from the speakers. It shows that these are experienced persons, and of course, the atmosphere is, I mean, cool to understand everything. That's from my own end, of course, from the feedback that some people also send. So thank you once again for being
I want to quickly add something before you go. So when I started with the story I started with a beer. I never ended it. Now, fun fact is that after applying the analytics on it, every month or quarter, I actually have a Power BI dashboard that tells me how much beer I have consumed in the month, and it's actually connected to what I call an approval process. So, and funny enough, my wife has the approval power. So if the beer goes down and I request for restocking, she goes to look at the chart and say, no, you had too much beer in the space of how many we can. Actually, she denies that. So don't think of it as far-fetched. Don't think of it
Oh,
as
you might.
it is. Don't think of it as, it's only industry. You can apply it to, everyday things in your house, analytics and insights in the house as well.
Okay, so you want to take that again? I think there was a glitch somewhere. Please
Can you
kindly take
can
that.
you hear me now?
Yes,
Can
I
you hear
can
me
hear you
now?
now. I think there was a
Yes.
glitch somewhere, so you can take that again,
Okay.
please.
Okay. So I was saying that, I started with a story that I automated counting and
Your
figuring out how
consumption
much
of
beer
beer.
I taken.
Yes.
Now, at the end of the month, there's a Power BI dashboard that tells me the amount of bottles I have consumed. And then there's an approval process that goes through my wife to determine if she's going to buy me more beer. Now, if she looks at the Power BI dashboard and thinks, no, my husband, you've been drinking too much beer, and therefore
I
you
think
need to
I,
drink
I,
some
I
healthy
think
juice.
I'm part of those people that want to see the dashboard. I think I want to see the dashboard. I
Yeah,
think I want to see it.
yeah, yeah.
So
So all I'm
this is
saying is that don't
yeah.
don't think don't think it is just industry. It is just big businesses. No, real time analytics can be just everyday things around you. And today it's very easy to do, right? Today there are APIs or things that even your phone. If you have your phone, those that are running iPhones, right? There's actually a section where you can tell your screen time, how long you've been on the screen, right?
Yeah,
And these are real time data that is your phone is sending out that Apple and the rest are using to tell you,
yeah.
hey, you're spending too much time. So there's a lot of things, around us. Oh, definitely, I'll share the dashboard, but please don't criticize me because I've been drinking too much beer. Yeah, yeah,
Oh
yeah,
it's been awesome because see everyone is looking forward. So I'm looking forward to that so that I can also give you an approval on number of bottles.
I know, right?
No. You know what I'm gonna filter out what you take on the average per day. I'll create a measure to see that.
I know, right? Yeah,
So thank you so much. Thank you so much. Of course, I know that it's been an awesome time with you. Of course,
yeah,
all the time it's amazing, Mr. Paul. It's been awesome. So thank you for that. So everyone, what you can see on our screen is that we will be having this, of course, just like Mr. Sam is saying that dashboard in Power BI will now show the consumption of beer. But my point is that the data will
yeah,
now be visualized with Power BI so that we can actually
yep,
see how it is. I mean, it's all synchronized because Microsoft Fabric, this is not Power BI standing alone. All of these that they
no,
are saying is that it's in one place, under one umbrella, all right, so that Power BI will just visualize all of these that we've been putting together. So once again, thank you everyone for being here. Mr. Sam, it's always nice to have you, I mean, talk from your world of experience. Same goes to Mr. Paul. Our people, participants, you are awesome. Thank you for always being here. These that are giving us for free as a community is what some of us paid for. And of course, thank you for always staying tuned. See you next week. Do not forget to drop feedback. That way we'll get to improve. We use it. Of course, we analyze the Power BI can tell us what we are doing
yeah,
and what we are not doing. Of course, you can also do live streaming to say, okay, as they are dropping the feedback form, let
yeah.
us be so we can ingest that into this. And of course, everything at the end of the day will make sense. So, Mr. Sam, shout out to people in Accra. I hope
Thank
someday
you.
I
Yes,
can.
at the moment, I'm actually not in Accra, so you can see that I'm in a very different environment. I'm in
Oh,
another state, as you people will call it. I'm in another region, also doing another volunteer philanthropic work, and that's how come my setup is not what the usual you see me in the studio. But we thank God for messages and being able to do this. But anytime, I'll send my greetings to them and hope to see you again in Nigeria pretty soon.
of course. Awesome. Thank you, everyone. And of course, see you next week. Do not forget to drop feedback, please, because we will need to make informed decisions with that. So, once again, thank you and stay blessed. Bye for now.
Thank you. Bye.
Yeah.